Hello, my name is Maurice, and in case you didn't know, I'm a cat. And I like to do puzzles. This is another one of my world famous puzzles. In fact, in this video you will get 3 puzzles for the price of 1. So there's a bonus for you. You will see that we have come into our office to film these puzzles. This is because we are going to use the whiteboard to draw out the puzzles. The answer to all of these 3 puzzles may appear obvious, but the trick is understanding why. Without further ado, here is my very dull assistant with the monotonous voice to give the first puzzle. Here is the first puzzle. 2 brown upright poles of different heights are separated by W meters. The top of each pole is joined to the bottom of the opposite pole with an elastic cord, as shown in the dotted lines linking the poles. We can assume the cord doesn't sag. The height where the cords meet is a distance we will call h above the ground. Here is the puzzle. If the right pole is moved to the position of the red pole and the cords remain attached, will the height where the cords cross remain the same, be higher or be lower than h? The answer will appear in a few seconds, so pause the video if you want to answer this puzzle yourself. We can see by drawing it that the height will remain the same. It doesn't matter how far apart the poles are, the intersection always stays at the same height. But let's try for a more mathematical explanation. Let's do this by using specific examples. We'll redraw the diagram slightly and assume in the first instance that W equals 20 meters and the 2 poles are 15 and 10 meters. Let's first of all find the height h. We'll call the distance from the left pole to the intersection point Wx, and the distance to the other pole Wy. We can see from the diagram that there are a number of equivalent triangles from which we can see that h over Wx is equivalent to 10 over 20. So h equals 10 divided by 20 times Wx. We can do the same from the other direction. h over Wy is equivalent to 15 over 20. So h is also equal to 15 divided by 20 times Wy. We know that Wx plus Wy equals 20, so Wy equals 20 minus Wx. Let's put this into equation 2, and equating equations 1 and 3, we get the answer that h equals 6 meters. Now we will move the small pole 10 meters to the right and repeat the process. This time, W equals 30 meters. The maths is slightly different, but the result is still the same. H equals 6 meters. So no matter how far apart the 2 poles are, the intersection is always the same height. Thank you for giving us that wonderful explanation. Now, here are your bonus 2 puzzles. Each of these involves guessing what proportion of the 2 shapes is coloured in. In the left-hand puzzle, a point inside the square is connected to its 4 vertices. What fraction of the square is shaded? The point can be anywhere within the square. The answer is obviously a half, but why? In the right-hand puzzle, a rectangle is constructed from the midpoints of the sides of a regular hexagon as shown. What fraction is shaded? The answers to these will appear in a few seconds, so pause now if you don't want to cheat and solve this puzzle on your own. Okay, here is the solution. First of all, let's draw a few construction lines on each diagram. On the left-hand puzzle, we have created 4 rectangles. We can see that each rectangle is divided equally in half along its diagonal. So it becomes clear that the shaded area is exactly half the area of the large square. In the right-hand puzzle, counting the number of blue and white triangles within the hexagon tells you that the shaded region is half the whole. So there's the solution. Pretty easy, wasn't it? Thank you for watching this video. If you like puzzles, like me, then why not try one of my other puzzle videos, or subscribe to my channel by pressing the round button which I have placed over my assistant's face. Bye bye and keep puzzling.